Howdy, hackers, and welcome to another episode of FairLight TV. This time we are bringing LFT, Linus Åkesson, one of the coolest guys still active on the C64 platform, doing amazing stuff, and most often also kind of not doing it the standard way, but finding a new angle. And also kind of working in the space where software and hardware both becomes relevant. We had an almost 2-hour talk, and we had to quit because Linus had another meeting, and also there was a restriction on Zoom because somebody else was going to use the account. Whoops. So we simply had to quit before we were actually finished. My ambition was to have sort of a director's comments on a few of his demos, so we will need to get back and have a separate episode of that because there are so many things in his demos that needs somebody with an insight to actually tell you what it is for fully appreciating the technical complexity of what is actually presented to you. And to be honest, looking through the interview afterwards, I can already tell that I sort of missed one thing in my notes. It's the Dial-A-SID. So he took an analog rotary phone, and then when dialing using the dictionary or the phone book that he supplied with that, then you can actually you could ring and listen to all the tunes from a different year or all the tunes from a different artist. So it would sort of make playlist on the fly. Just an amazing thing that very few people would be able to do, but Linus is for sure the one that would be able to do it. So but that is just like a little sample of what Linus is able to do. So yeah. Let's skip me talking about it. Let's hear Linus talk about it. Over to Linus Åkesson. Hello, everybody, and welcome to FairLight TV. This time we are welcoming LFT, the true multi-talent who has been doing so many things on the Commodore 64. So, hello, Linus, and welcome to FairLight TV.
Hello, it's nice to be here.
So you are one of those like multi-talents. You are doing code, you are doing graphics, you are doing music, you are doing tools, you do them on the C64, you do them on like Linux platform. You're also doing a lot of hardware stuff. So let's start with that question. Is there anything you can't do?
Yes, I'm sure there is. For instance, in the graphics department, I do what I can, but I have a long way to progress if I want to be a master there as well. I think music and technology is where I'm coming from, and I think it's fortunate when you have two different interests, because then you can combine like what is common knowledge in one area and sort of not impressive among the people who do that sort of thing. You bring that knowledge to a different area, and it's suddenly something very impressive and new, and you can go both ways. And so it's nice to be able to combine two things. That's general life advice.
Great. Me being a lawyer working like not in typical lawyer stuff means that I'm rather special in what I do. So I fully acknowledge that is a very good idea. Very good idea. So let's start with the obvious. LFT. What is that? Is that your name or?
It's my handle, and it has a story. So when I was a kid, I grew up with the Amiga, and I was swapping games with my schoolmates, and there would be these cracker intros, of course, and being a kid and just figuring things out as I went, I had no idea. I mean, when you start something like Pinball Fantasies, there's the cracker intro, then there's the distribution logo, whatever, Psygnosis or whatever, and then there's the name of the production house who made the game, and you have no idea as a kid what the different logos are. you learn this intro sequence by heart and you love it for what it is and all the different pieces of music in it, but you have no idea what's what. But there were these brand names that were like FairLight and like Crystal that would be used a lot. And at the age of as a teenager, you like to parody things and you like to sort of make your own name in a way and reference things. And so I started to use a pun on FairLight, which was Lairfight, as a handle. And then I also took the slogan that Crystal was putting in their intros, which was accept no imitations, and I would say accept no limitations as my slogan. So I was Lairfight, accept no limitations, and that was my moniker on BBSs and so on. And then at some point I wanted to shorten it to something more convenient to type and shorter, and it turned out to be LFT. And then when the joke, the FairLight Lairfight joke, was getting old, I didn't sort of want to stick with the old longer name, so I just dropped that.
So it is actually kind of a mockery of FairLight. So
yes, it is. It started that way.
I had no idea. That's really cool. That's really cool. We don't take that as an insult in any way. So really cool.
I'm relieved.
Yeah. So and Kryo, you started that in 2007, and it was basically you and a guy called Jarek, and we haven't seen anything from him.
Yeah, so the thing is, it started a bit earlier. It's a group of friends, and we had a common interest in computers. We did stuff like we ran a server. We developed some PC tools. There's a tool for tunneling internet traffic through a DNS protocol, for instance, that we did. And some of us also went to demo parties, or the bigger combined gamer LAN demo party things that we had in Sweden in those days. And we also we didn't release demos under the label Kryo because, I mean, I made some stuff on my own, but we were just a gang of friends with that name. Then we went to a local C64 party, which was held in Lund, and I worked on this hardware chiptune project, which is, if you go back to my earliest YouTube video, it's just a video of microchip playing music. And that was something we worked on this C64 party. It's not a C64 project. We had no idea what we were doing there. I actually went home to sleep on Saturday evening because I didn't realize that that's when the main attraction of a demo party would be. So I missed the compos and everything. But we worked on that project and released it later at Birdie, I think, as a wild compo entry. So that was our first Kryo release, and that's why my YouTube channel is called LFT Kryo, because the first video was something we did together.
Yeah. Okay. Cool.
And then we also made, Jarek and I made a C64 release that was a party production. So we went to Breakpoint in Bingen, and we just sat there and had a good time. And then we thought maybe we should make a C64 game. So we just downloaded the shoot 'em up construction kit, the FairLight cracked version, I remember, and and we just made a game for fun. And of course, we had no idea what we were doing at that time, so we didn't realize that we had fast drive emulation on. So when we were testing, everything was very smooth, but during the actual compo, they had true drive emulation, so everybody had to sit and watch like 1 minute of flickering raster bars.
Oops.
Before we were able to demonstrate the game. But it was fun.
But I mean, taking that back one step. So, I mean, you are a number of years younger than most of the people who are sort of active today. Most of them were born around like from me 68 to 73-ish, and you were younger than that. So how did you even like come across the scene? Because you would need to kind of look us up, because we would be old farts.
Yeah, I did have some experience with the C64. So my uncle had one, and some of my friends had the C64s. So I knew about them, and I had tried them out. But my own computer was always the Amiga, and I stuck with my Amiga 1200 for a very long time. So I sort of until Linux was an option. I never ran a Windows PC, but I was an Amigan, and one thing happened in what we say in Sweden, gymnasiet, which is the sort of between high school and college, where we had these graphing calculators. So we would use them for math class, but there were also games. So you could download little games that ran on this calculator. And I was interested to program the calculator. So I wired up my own transfer cable and starting playing around. And this was a machine where everybody had exactly the same hardware. So unlike the Amiga or any modern computer where you have to sort of follow the rules and do what the documentation says that you're allowed to do, on the calculator, I could just do anything and trust that it would run on every other machine. Now, it turned out that this was a wrong assumption, because TI changed the hardware later. So those the game I made and the little demo I made, they can't run anymore on commercially available calculators, but you can emulate it, of course. But that experience of having the same hardware as everyone else and being able to sort of discover new hacks and use them, that was very intriguing. And then at some point I learned about microcontrollers and little chips that you can program where you actually have the physical hardware. So you know it's only going to run on this particular machine. You can do anything you like. You can do some hardware hacks around it even. And so I wrote a demo for a microcontroller called Craft, and I released that at Breakpoint. And that was sort of like a bombshell for that scene. Where I just arrived suddenly with this overnight. I didn't expect the kind of response that I got either. I mean, people were cheering, and it was a great experience to show that on the big screen. And then I was a noob. I had booked an early flight home, so I missed the prize ceremony as well. So you learn these things as you go. The
hard way. But yeah. Then, I mean, going to Breakpoint, that means that you somehow sort of found that is a thing.
Then I noticed what the demo scene were doing, and I noticed that within the demo scene there was a core demo scene, which was the C64 scene.
Oh.
And so that in combination with this C64 party where I made the hardware chiptune project, it sort of grew on me that there was this inner circle of the demo scene, which was, and then combined with my interest in cycle accurate coding, where you know the hardware and you can do these sort of tricks. I remember talking so because Breakpoint is in Germany, you talk a lot with the other Swedish people who happen to be there, and I got to know Radiant. At that time, it was called Radiant X, and I remember when I said that the programming microcontrollers is very fun because you can do these cycle counting tricks, and I said that this is like the old home computers. But it's happening now, and he said something very calmly, like, "What, the old home computers are still there?
Yeah,
you can program those too," and that's I guess the starting point.
So it's all thanks to Martin. Great work, Martin. You brought him in.
Yeah.
Great. Yeah, and Martin is also he's sort of your age, right?
Yeah, I think so. Yeah.
Yeah, because you are like 10-ish years younger than I am, and but so I was celebrating Martin's 40-year birthday the other day. So
Mhm.
great stuff, great work, Martin. So the first time I think that I heard of you, it was this safe VSP, and that seems like one of
Mhm.
the early things you dug into. I haven't sort of explored your Amiga production. Should we start there? Have you done a lot on the Amiga as well that would be
Um,
released and available,
Not
or?
really. I mean, yes, I did tinker, but I wasn't very good. So that was like how I started out with Amiga Basic, and then assembly language, and then C coding as well. But I never sort of made anything impressive on the
Yeah.
Amiga. I made little tools as well. And when I later, when I was putting my Amiga back together a few years ago, I wanted to sort of recreate. I had an old screenshot from what my workbench looked like, and I tried to recreate that. And I noticed that there was no title bar on the screenshot. So I sort of remember that I used the tool to get rid of the title bar, but I couldn't remember what it was called. And so I went to look on Aminet, and then I found some tool that I thought this looks like it will do the job to hide the title bar. So I downloaded it, and it turns out that I wrote it. So so I did release a little tool for hiding the title bar on the workbench screen.
Okay. So if I haven't dug through your Amiga history, I haven't missed anything significant except this
No.
hiding of a title bar.
Yeah,
And to be
exactly.
that's
The
that's
sort
not
of
really
that's the pinnacle of
that's
my
that's
of
not
my Amiga
really
release.
graphically impressive as well. So it doesn't sort of manifest very
I
nicely
made
on the
I mean
video. So, but
I made some joke productions, and I made some, yeah, some games, I guess, but nothing interesting. I mean, it was something we shared with people at school, and yeah,
I'm sure it's preserved somewhere. So yeah, well,
possibly.
when you
Yeah.
watch this and you know any reference to any of the LFT stuff on the Amiga, do share links below, and we all have the opportunity of watching them. But we won't go through them in this video. We will go to the C64 and the other stuff, and there is a lot of other stuff. So let's start with VSP. For those who do not
Yeah.
know VSP, what is it, and what is the problem, and how do you solve it?
Yeah, so as I was learning about the C64, I read the VIC article, which is an excellent white paper about how the VIC works and how the various effects that you can do with it are sort of come about. And
Christian Bauer's text, right?
yeah, exactly. And
Who wrote the Frodo emulator, I believe, as well. So
that sounds reasonable. I didn't know that, but it can be certainly be that way. It's a very well written article, but it doesn't mention, it mentions VSP, but it doesn't mention the VSP bug. And I thought that this was sort of the best effect. Just after reading through the article, this was some sort of really useful, really powerful, and really technically interesting effect to use. And then I started, I don't know if I noticed it like on my own when I tried it out, or if I read about this problem with it. And the problem is that sometimes on some machines, when you do this effect, the memory becomes corrupt and everything crashes. And that's sort of a deal breaker when you're making a demo to show on a big screen on a competition. So, but then I also hang around on the C64 IRC chat. I don't know if it was there or if it was on the CSDB forum, but I noticed that 0x from Finland, Tommy, had captured a VSP crash using a logic analyzer. So he had recorded the various signals, and then he wrote something like, now I just need to figure out how it happens or what's going on. And that sort of tickled my interest as well. So I started looking through his data dumps, and I noticed the problem, or what I thought could possibly be the problem. And it was that when you do this VSP trigger, the VIC chip suddenly switches the address that it's reading from. And it does this at a time when the address lines have to be stable. And sort of what happens is that the memory will then become confused and open many memory rows at the same time. And the content of those memory rows will bleed together. And that's why you get memory corruption. But what I also noticed was that this will only happen between memory locations that have an address that ends with 7 or F. So it's on every 8th byte throughout memory that gets corrupt, but all the other parts of memory are intact. So I wrote this demo that would skip or sort of, well, the code has to skip every 8th byte. So not only do I have to count clock cycles, you also have to count bytes as you're writing the code. And and I also converted my music player to be in this under this constraint. And then the graphics, you really can't skip every 8th byte, but you can restore it. So you can continuously sort of copy back the correct values into those memory locations. And yeah, and so I made a demo about it, and I brought this demo to Datastorm in Gothenburg. And I had hoped that on a demo party there would be lots of C64s, and some of those would have the VSP crashing problem. And so I would be able to test my demo before releasing it, just to make sure that it actually solved the problem. But I hadn't realized that people wouldn't bring crash-prone machines to a party. So everybody just had their fully working machines instead. So I couldn't test it. So I had to wing it and and release it anyway. And it turned out to work. So that was good.
Great. So and VSP is when you can position the screen like any way.
Yeah, it means
delay
variable
screen positioning. You are delaying the fetching of the screen pointers to a later position on the screen, and then the screen appears. So it's a way to scroll the entire screen without the issue of actually moving data around. It's a really fast way. But
yeah, so the C64 has actually a fixed screen map. You can choose between different banks of memory, but you can't say start a little bit down the image. There are some tricks to move vertically by delaying the video fetches and by skipping entire rows of text. But the VSP is necessary if you want to move horizontally or really quickly move a long way down the screen. And it's really useful for the sort of color cycling effects that Sensor use a lot, for instance, and I use a lot as well. Without VSP, those would be very hard to pull off.
So you move the colors, and then you have, what do you have? Like sprites in front of it? And
you have two bitmap images, and then you switch between them, and you update only the colors. And then you can create things like the wobbly moving text in the acid pills demo from Sensors, for instance. That's a good example, but there have been all kinds of wobbly scrollers since then. And many of the effects in Lunatico also work on this principle. You switch between two bitmaps.
Great. Let's see if we can make watching Lunatico in the end, and yeah, because we have a time constraint here that we need to adhere to. So let's go through the next thing, Spindle loader system. So like most demo coders would use somebody else's the Bitnac or back in the days, you just added Pink Floyd to your projects, and that was the really old loader, when you had like demo parts, and then you had Pink Floyd loading with the flashing screen, and then it would be the next part. But now with the more thematic demos, that wouldn't be possible. So now we have Spindle as one of the options. So what is Spindle?
Yeah, so I would say this started, I watched a seminar on YouTube by Ninja, where he goes through a modern C64 track mode or track track synchronized demo. I think trackmo refers to the soundtrack and not the disc tracks, but that's just my view of it. And he mentions that, yeah, you have to have a loader. There are many to choose from. Back in the old days, everybody made their own, but now there are some that you can just use. You need to reserve some part of memory for the loader, and then you just call it. So I knew about loaders. I knew sort of how they worked, but I didn't. I had no reason to make my own loader at that point. But then when I made my first C64 release, I would say that's the dance game, the Hardsync, I call it, where I connected a dance mat to the C64 and running a lot of SID tunes, well-known SID tunes with arrows, and you have to step on the arrows in time with the music. And I wanted to make my own loader for that, because I had also found there's this article from Covert BitOps, which takes you through how to make a very simple fast loader. And that felt like something I would like to try. And so I implemented according to that, and that worked for a while. But so at that point, I sort of had my own loader, but it wasn't good enough to make a state-of-the-art demo on. And then I became interested in this GCR decoding thing, which is going on the disk. So on the magnetic medium, you have to flip between 0 and 1 every so often, because those bits are also synchronizing the clock for reading the data. And so you have to encode the data in a way that wastes some bits in order just to keep up the changes from 1 to 0 and back.
Eliminating all the scenarios with only ones and only zeros. You need to have...
Yeah, exactly. You can have at most 3 zeros in a row. Then you need to have a 1. 1 is when the magnetic polarity changes. And that to decode that data into proper bytes is something that the built-in firmware on the drive, it uses tables in ROM, but it doesn't really do it very quickly. And so you have to sort of read everything to RAM and then decode and then send it over. And what the modern loaders do, like the the state-of-the-art loaders at that time did was to sort of start converting some of the data while fetching it, and then leaving a final pass to later, to during transfer, for instance, or even as a separate stage. And I looked into that, and I read about it in the forums on CSDB, and I sort of got the impression that this was not possible to do, but it was kind of close. So it was intriguing, and I was reading through the source code for Krill's loader. That was a big inspiration that he released that as open source. And I saw the decoding loop, and he had also documented how it worked. So between this cycle and this cycle, you have to read in order to get like these bits from the second byte and these bits from the third byte, and then decode them later. And yeah, so everything was documented and the constraints were there. And I started looking into, maybe I can implement this. Sounds like a fun thing to do. And then I also ran into this problem that you could almost do it in the time before the next, because you have to keep up with the spinning disk. So you have to do it quickly enough. And then I got to a point where I was like only a few cycles away from getting something that will work. But I still, of course, you can't try it. If it's almost there, you can't try it on real hardware. So you don't know if it's going to work. And then I suddenly figured out a way to do it precisely within the time limits. And then I would be able to try it, but I could only try it, I mean, in the context of loading something. So I only had the tight inner loop. I had to expand that into an actual simple loader to try it. So it took a long time before I was able to verify that I had actually figured out how to do it. And once I had that, I decided I wanted to use it in a demo. And so that was my first C64 demo, Shards of Fancy, which was built around this new loader. There's a part where I'm boasting about the GCR decoding, which is like for maybe 3 individuals in the audience who were impressed by that, but still, Krill was there.
Yeah, he should be one who would be impressed, because I mean, he knows his the 5041 is his domain, sort of.
Yeah. And so I did that. I was quite happy with the result. And then I released it. But no, did I release it at that point? Or maybe I thought that I would develop it into a releasable loader. I don't remember if I released Spindle at the same time as Lunatico or just before it, maybe. I do remember that Lunatico is a 2-side demo because I wanted to implement disk flipping in my loader. And then when I had implemented it, I had to use it in my demo.
Of course.
So otherwise, maybe it would have been a one-sider.
Should use loose packing to ensure that it's not taking too little space on the disk.
No, but then you fill up whatever space you've got anyway. So.
Cool. So that is Spindle, and that implements. So your GCR decoding on the fly is also implemented in there, and that's one of the reasons it's loading faster than most other things. Yeah.
And then I sort of paused my development on Spindle for a while. I had other things that were shinier. And Genesis project needed some improvements made. And when I didn't do them, they developed their own version called Sparkle, which is, they credit me as an inspiration, but it's their own implementation from scratch. And they do some things better. And so I had to look at that and see, well, yeah, you can do it that way. That's cool. And so I started developing Spindle and making it as fast as Sparkle, and adding some other features as well. And so when I released that, I made a little demo about it as well. So I made a little advertising demo. pushing for
and
the new features.
that was version 2. So I mean, again, so Spindle is it's not only the loader. There is sort of a scripting thing around it. So when
That's
you are
right.
implementing your demo, you are implementing this scripting thing to ensure that. So this builds the entire process. It takes all the nuance out of the linking, which is typically a nuance where you do that, which you do rather late at night at a party where you want to drink beer and not really do this crappy
Yeah.
part of demo coding.
Yeah, that's automated, which is a feature that many people like, of course. There's also the whole demo making framework around it, which was in the first release of Spindle. That was the only way to use it. So you had to fit your parts into a sort of an API for how to set up the part and what to call in the interrupt and so on. That's something that's now optional because many people still want to do the demo in their own way, but they want the benefits of the fast loader. So there are 2 ways to use it now.
Excellent. So when you're doing demo with more than one part, and now if you think about implementing a demo where you have a demo part and then you press space and then you call Pink Floyd to load the next part, that's not the way you should do it. You should do it more like the Spindle way. So right, we move into the next thing. This pronunciation, my apologies if that becomes strange, but Zeugma.
Zeugma. I think it's Zeugma. Yeah.
Okay.
Yeah. So that's for text adventures. So I have also been, at that time I was sort of a lurker in the text adventure community, which is another little subculture that many people are unaware of. But so text games were big at some point in the 80s, and there was a company called Infocom that turned it into a literature form. Really, they made some really good interactive stories, really, and released them as text games for multiple platforms. And in order to do that, they had a virtual machine. So they only had to port this virtual machine to different computers and then write the game once. And it's called the Z machine, which is short for the Zork machine, because the first game was called Zork. And this machine has interpreters on the C64 and other computers, but the machine specifications have increased over the years. So some of the later games from the 90s were not playable on a C64. And so I thought, well, this virtual machine has been reverse engineered and documented in a very well-written document. It should be possible to just implement this on the C64 and be able to run the latest text adventures that people are writing now, because a lot of things have happened in that game design space. So it's quite a different experience to read a modern interactive story compared to the old text adventures. And I wanted to bring that to the C64, so I implemented the virtual machine, and it was very, very slow, unfortunately. So it turns out that these modern games are not, because they are developed for interpreters that run on modern computers, they are not coded very efficiently. So they sort of run through every object on every move and compare things in a way that you wouldn't do on a slow computer. But by that time I had already implemented everything. So, and you can run some games from the 90s. So you can, it serves a purpose.
But I mean, one of the things is that you implemented support for RAM expansion units. I guess that's one of the things that makes it less slow, I would say. So
yes, certainly, and I think it would be unbearably slow on a floppy drive, swapping from a floppy drive, because I mean the games are so big now. So, but then I've also done other text adventure stuff since then. So I made my own virtual machine and my own tools and wrote several games, and some of those are available on the C64 and they run smoothly. My latest game is too big for now, so I have to improve the tools in order to make a C64 release for that. But maybe sometime.
your implementation here, you are only using the Rio for storing the actual game, so you skip the disk loading part. You're not using it as part of the interpreter for speeding that up in any way.
Yeah, in Zeugma, it's only pretending to be a floppy drive, but that means that you can swap more aggressively because it's rather cheap to swap in a block. So you can simplify the swapping algorithm as well. But it's essentially acting as a big floppy drive, yeah.
Okay. Yeah,
in my own virtual machine that I developed later, the REU is also used as an undo storage. So you can sort of undo your latest move. And yeah, that's useful as well.
Excellent. So yeah. So we should say that Linus Åkesson.net is the place for all the documentation. And if you compare with other people, Linus is documenting everything, and there is a well-written text or even a video about everything. So so this talk we're having now is basically a teaser for those who want to deep dive into the specifics. They are there.
Rabbit hole. Yeah, it's there. Well, I mean, I won't say everything is documented, but when I do document, I try to do it properly because it's very nice when people do that. I mean, when you find well-written documentation, it's so nice. So yeah. I want to provide that when I feel like it, and otherwise I don't write anything at all.
Yeah, that's excellent. So the next piece is something that sort of shows that you do have an Amiga background, and that is Ultimate Opus. For me, Opus, I mean, Directory Opus, anybody who's ever been on the Amiga would have used Directory Opus. And I guess there was a big discussion on the move from, I think, version 4 to version 5, where version 4 was the standard two window thing, and version 5 was something more fluent.
Yeah. They went off the race. What?
So Ultimate Opus, what is that?
Yeah, so the 1541 Ultimate is a cartridge that also includes a 1541 emulator. So you connect it to the cartridge port, but also to the serial port. And it has a little API where from a C64 program, if you enable this feature, you can actually read the files on the USB memory or on the SD card using some hardware registers, and then you can access these files much faster than if you emulate a floppy drive. And this also lets you organize your files and create directories and move copy files around. At least nowadays, you have all these features. Back when I wrote Ultimate Opus, you could at least copy things, but making directories, I wasn't sure if that's what's implemented. But my vision was, because at least at that time, there was an SD card slot on the Ultimate, which was hard to reach. So you had to use a little flathead screwdriver to get the SD card out. And there was no way in the native browser on the cartridge to move files to or from the SD card. Later, they have added features for that in the firmware. But at that point, you had to use the screwdriver, take out the card, put it in a computer, move your files, and it was a nuisance. So I wanted to make a tool to simplify that, so you could do it on the C64.
Right. So again, the interview I had with Fredrik doing Assembly 64, he basically wanted to solve the same problem. This little micro SD, and it was wobbly, and it was easy to kind of put on the wrong side of the board, and he would just go into the package and needed to open the package to get it out. And so he wanted to solve the problem, but he didn't do it on the native 64. He did it via the LAN port, I guess. So
yeah. Cool. And I was, of course, inspired by the Directory Opus, where I call it Ultimate Opus. Yeah. And I have been working more on that tool as well. So here's a little teaser for something I haven't released. I'm working on a cartridge image that would be compatible with a retro replay, because the Ultimate can emulate a retro replay. So normally you would run the Cyberpunks or some other image there, and you would have your fast loader and your disk copy tool, for instance, there, and your monitor. And I have implemented my own replacement for that, which has a monitor and a fast loader, but also a directory browser, which is also like directory Opus. So I'm taking this project further by baking it into a cartridge image. So it's there when you power on. So immediately you'll get this directory Opus view.
Excellent. Is it possible to submit modules you add there? Because when I use my action replay, there are aspects of the action replay that I'm using on a regular basis, and that would be the sprite viewer. I really miss that, and I cannot for the living, for any reason whatsoever, realize why they've thrown that out. It's not in the retro replay.
That's an interesting feature request. I hadn't considered a sprite viewer, and I realized that everybody will have their own sort of favorite thing. So a module system sounds like a good idea. It is a bit cramped when you're writing for a cartridge. You have to think about what to put in the various banks and how to make it all fit together. But maybe that's something I will look into. What I do have is configurability. So the sort of the buttons or hotkeys at the bottom of the screen would be completely user configurable, and colors and banner texts and things like that should be configurable. And so what I have, for instance, on my musical instruments that I made on the C64, usually I don't have a monitor plugged in. Then I want to load some specific program. And because I'm using this cartridge image with hotkeys, I can start a program from the USB stick by just like doing Commodore Q or something, turning on the power and then hotkey combination, and then my program is up and running. And that's something that I think a lot of people could find useful, to be able to configure a hotkey to launch a program directly from USB.
Well, to be honest, I mean, the native action replay does have some sort of module system. So there are a rather limited set of like third-party tools which you can load directly from the menu, and I guess they also work in freezer mode. But for me, the sprite viewer thing is a good thing, or generally scouting around for graphical elements in the program. When reassembling things, I want to know where things are in the memory, and nowadays I can use C64 debugger on the PC, but again,
but in the context of a native tool, of course, you have to. Yeah, it's interesting.
Yeah, see that as a suggestion. Moving into time is ticking here, and I'm really worried that we won't have the time to go through everything. But I guess Torsten will have to put add videos of you playing your instrument, so we can just do the theoretical part. So. Blackbird, the music editor here. Yeah,
that also. So when I made my demos on microcontrollers and other hardware, I would often sort of throw together a little tracker that ran on Linux in the terminal. So everything was text-based, and I could edit and listen to little tracks, little parts, and then there would be connected to some sort of emulation of the sound. And so it was easy to swap that to a SID emulator and make my own SID tracker on that would run on Linux. And when I was making Lunatico, I had this idea that I wanted to integrate streaming music into my loader. So you would compose a long piece of music, and you would load it one part at a time, and that would be integrated into the demo making framework. And so I made a tracker on Linux in the terminal for making that music, and I also made several of my compo tunes in that tracker. And then at some point I started thinking that it would be nice to port this tracker to the C64 because it's fun, but also because the SID chip emulation that I was using wasn't exactly right. So sometimes there would be a little click or something on the real thing that I hadn't foreseen. So and the filter emulation was also not exactly as on the real thing, and that of course turns out to be because every SID chip is unique and every C64 is unique in its filter setup. But I didn't realize that fully at the time, and so I wanted to run it on the real hardware, and I started coding it, and yeah, turned out to be useful. So I used it on my own a few times, and then I released it.
I caught this streaming thing. So is that having the same player, and then you load new music, and then you just point that player to the new music? So you basically don't need to change the player between music.
Yeah, exactly. Right. So there's a part there's a resident part, which is always in memory, and that's the player. And there's some data like the instruments and the arpeggios. Those are always in memory. And then there's a buffer, or actually two buffers, one that is in progress of loading and the other which is being used with streaming data. And so normally in a music player, you would have patterns, and you would have some kind of song structure that points to the patterns, and you would reuse a pattern as much as possible to save space. But often in practice, as a musician, you often want to sort of reuse most of a pattern, but change a small thing somewhere at the end, perhaps. So it feels like you're wasting memory, but you have to do it musically. In my streaming version, it uses a kind of compression. So you have your buffer, and you can refer back to within that buffer and copy bits again. So it works a bit like a normal decruncher. So you have literal items, and you can also refer to old data. But when you refer to old data, you can also transpose the notes in that data. So like a short string of notes can then be copied and reused at a different pitch. And that turns out to compress reasonably well, so that my SID tunes have roughly the same size as a normal compo tune. But when you copy a pattern and change just a little bit, you still get the compression. So you still get only a small increase in size. So that's a benefit, and also this streaming thing. So as long as you have your look-ahead buffer of like 256 bytes that you can for referring to old material, as long as you have that, you can sort of throw away the older stuff.
So you can have, if I try to understand that, you can have a pattern, and then you have a new pattern which you change ever so slightly, but it's still a new one, and you're basically repeating data, but because you are compressing it, it basically just adds the little extra footprint of the delta, basically.
Yeah, and so in the Blackbird tracker, you are working with tracks, but when you export, and the exporting tool is a PC tool, so that tool is going to put everything linearly for each voice, and then compress that. So the information about which pattern numbers you use, that just goes away when you export. It becomes a linear stream.
Great. Yeah, that flew a bit over my head, but I got sort of the gist of it, I guess. We move into charcoal, and of course you've done a paint program. You're not only painting, you've done your paint program, because none of the others that were on the market, like the 500 of them, would do, right? So
yeah, so I got into Petsky. Petsky is a very nice, I think, gateway into C64 graphics, because you can tinker with it and get some very nice results very quickly. And then of course there are several people who master it and craft very amazing Petsky art. So you have something to strive for, but you can also very quickly get something on the screen. And when you're learning Petsky, you have to learn about the characters that are available. And there's this PC tool that everybody uses, where you have the characters on the screen and you drag them onto the picture. And that tool also allows you to I forget the name, so I won't mention it because I'm gonna mess it up. But it's a tool that everybody uses, and you can use a brush technique. So you can cut out the rectangle, you can flip, rotate, and paste. And I thought that's kind of neat. I would like to do that on a party on the C64, because then I also have the pictures of the characters on the actual keytops. So that's another thing. Just like on Blackbird, I wanted to run on the real thing because the filter is there. I wanted to draw Petsky on the real hardware because the characters are printed on the keytops.
Yeah, we don't have any overlay for a normal PC keyboard. So yeah, I don't know if
it's probably gonna come in the future.
Yeah, there might be a Kickstarter for that eventually. Yeah. Somebody producing a keyboard with C64 keys on it. I mean, if they're doing real keyboards for the C64 Maxi thing, then I guess you can take that one out and just use that.
Yeah.
Excellent. Qwertuoso. That's also a sound editor, but this is something you written specifically for the accordion, right?
So Qwertuoso, I wouldn't call it an editor. It's more like a live performance tool, and what it does is that it lets you play the SID chip as you would play an accordion. So a button accordion. There are different kinds of accordions, and the one I'm talking about has a set of black and white circular buttons where you play melodies with the right hand. And those buttons are arranged in sort of a slanting grid. So you have straight horizontal lines and slanting vertical lines. And I realized that the keyboard also has this shape. And it has this shape for the exact same reason. So a typewriter would need to have a mechanical arm from each key, and they would have to come together into a straight line at the front. And the accordion has, for the same reason, every key has a mechanical arm that goes to a straight line, and then to control the various valves in the accordion. So I realized we could map the keys on a keyboard to notes in the same way, and that should be playable because people play the accordion and are very good at it. So it should be maybe even a better way to arrange keys than the typical way in a music editor where you have a piano keyboard. Because you can fit more notes closer together, so you can reach larger spans of notes without moving the hand very much. And it's also very, it's a brilliant layout because it's very symmetrical. And so you can learn the shape of one melody in one place of the keyboard, and then you can just move your hand and play the same shape elsewhere, and you get the same melody in a different key.
But I mean, so this program, would that be used by anybody else than you performing on your accordion? Or
I'm not aware of any other user at this point. But yes, it can be played by anybody. So when I came upon this idea to map the keys like on an accordion, it was kind of part of this bigger idea of making an accordion. So I already had this idea that I maybe should make an accordion from C64s. I hadn't at first figured out this idea of using floppies for the bellows, but once I started thinking about that, I realized that this is something I have to do. It's such a good idea. So I started working on that, but it took a long time. It was tricky in many ways to get this Commodorion thing working. And at some point I realized that maybe just playing on the keys on a normal C64 without mounting it together as an accordion would be useful in its own right. And so I released that as part of another project, which was the 64 gun, which combines the C64 with a reverb tank to make an organ-like sound. And so I recorded some organ music on that. And that's when I released Qwertuoso as well a bit later for general use. Even if you don't have a reverb tank, you can still play on it.
But for me, an accordion has buttons on one side, and then it has sort of the normal keyboard kind of.
Yeah, that's a different kind of accordion, which is common in Sweden, I would say. But the chromatic button accordion is also used. There are two ways as well of arranging the chromatic buttons. They can slant like in this direction or in this direction.
Yeah.
And the one I use has to be the one that works on a computer keyboard, and that's actually not the common way of arranging keys in Sweden. It is more common in Eastern Europe, for instance. Okay. But I mean, I had to use whatever worked on a computer keyboard.
Right. So I mean, your accordion thing here, you are using the same technique on both sides now. So you're not using like standard keyboard on one and then buttons on the other. You are using the two of the same.
I can do that. They are running the same software. So if they are both in the sort of freehand mode, they are both running Qwertuoso. But what I also have is the automatic accompaniment rhythm box mode on the left hand, where you program a short loop and then you have the ability to change the chord in that loop by pushing buttons. And that works in a way that is similar to the left hand side of a normal accordion as well. So you have the right hand side plays melodies. So that could be a piano keyboard or this chromatic button thing. The left hand will usually play bass and chords using a different button layout. And I'm inspired by that layout, but modified it a little bit to work on the Commodorion and added this looping thing.
Okay, we will get into the actual instruments because that is a segment of its own here, but that was just a teaser for that. So that was sort of software. Now we're getting into your music, and you have done a lot of music. I guess this 15 years of Scene Spirit, is that sort of a compilation, the best of Linus Åkesson?
Yes, on the SID, and then I also because I got myself a Spotify account or a streaming account, so I'm able to upload music. And I did release some old microcontroller tunes as one album, and then people wanted to hear SIDs, and so I realized, well, I can take my best of my hits and compile them into an album, and then make it a music disc as well and release that. So it would be a scene release, but also an album released on Spotify.
Okay, so all your stuff is available on Spotify.
Sorry?
All your music is available on Spotify as well?
Not all of it, but much of it is available.
I guess you are the guy to talk to about this theory I've had for a long time about having like a SoundHound for SID sounds. I would like my mobile to be able to kind of listen to what I'm listening to and tell me which SID tune it is. Something chewing on high voltage SID collection, and then knowing all of them.
One tool I already have released. It was many years ago, but I do have a SID theme search engine, so you can type in a melody, and it will then search the HVSC for matches. And if you're lucky, that melody is played in a very clean way by a single voice on the SID chip, and then it's going to find it. So you can, if you can play the melody on a piano, then you can also type in the notes in my search engine and find the SID tune.
Okay, but assuming I cannot do that, I mean the first stage should be replaced then with the listening to something that it hears. So
certainly that should be possible to do. Yeah.
Yes, please.
The original, the original Shazam algorithm is public. I mean, they have improved it since, but there was an original paper describing how they do it. So that would be a good starting point, I guess. And
If you release that as one of those wild compo releases, you will have my voice, my vote for sure, for sure.
Yeah.
Yeah, take that as a suggestion. That would be highly appreciated because, I mean, again, listening to SID tunes, I feel that, you know, the sensation that I know this, I've heard this 100 times, but I don't know which one it is. It's clearly Galway, but I don't know which one it is. So
right. Well, then in that case, you can listen through like 50 tunes and maybe find it. But if you know it's Richard Bayliss, then you still have a big task ahead.
Yeah. Okay, so we've already talked about the GCR decoding on the fly, and now more of coding feat here would be MISC, Massive Interleaved Sprite Crunch.
Yeah, that was a fun little trick I figured out. So there's a sprite collision hardware in the C64. You can, so in these really old games like Pong and so on, and early shoot 'em ups, it's tricky maybe in software to figure out if your bullets are intersecting an enemy spaceship. So there's hardware acceleration for that. You can check after rendering a frame. You can check which sprites touched something else. And if you only do it once per frame, it's really not that useful, even though it was designed for that. It's more like it makes the game development easier if you are making a very simple game.
Yeah.
But what I figured out was that you can do this on every raster line. And then you can very conveniently figure out for every sprite if that sprite collided with the background or not. And then you can have, like, in the far side of each sprite, you can have a pixel, and then you can have like a vertical black line in the background graphics, so you won't see these pixels, but you can read out on every raster line whether there is a pixel or not. And then that can be useful to then determine if you're going to stretch that sprite or not on the following raster line. Because then you have this sprite crunch thing, which I believe maybe Crossbow was the first to use. Actually, Palnord was the first to use it in Rutig Banan. But Crossbow also used it in order to fit very many sprites on the screen at the same time. And it's a way to trick the hardware to jump ahead in the sprite data. And you can use it to reach the end of the sprite earlier. So you don't have to wait the full 21 raster lines before you use the sprite again. But you can also create little loops in the sprite so that if you trigger this effect at the right time, you can make a short loop of maybe 11 raster lines or 13. You can't pick and choose. You have, like, there are different loops that you can use. And so then you can have sprite graphics that have slightly different height. So in my case, I used it to have wobbly balls with letters in them for scrollers. And then you can use this collision detection as a way to sequence when it's time to trigger the sprite crunch. And I mean, this effect, it's a very convoluted way of doing something that maybe would be possible to do in a conventional way. And so it's more of like a show-off technical thing. I mean, the description of the technique is maybe more impressive than what you see on the screen. But
right.
But I don't think you can do exactly that that effect in some other way. Maybe you can. It would be tricky to fit in the cycles, but maybe it's possible. But I doubt it. So exactly that kind of effect you would need to use this technique for, but you could get something similar up and running using conventional trickery.
I know one of the guys in Horizon, Exilon, master coder, not one of the more known characters in Horizon. He was called Krukis because he spent months and months of doing one little effect that was technically absolutely brilliant, but the way it looked on the screen was basically a kruka.
Okay, yeah.
Yeah, so it became nothing, but it was a technically advanced nothing. That was, yeah, thanks.
But
Really,
it's
really impressive, but we can't use it.
one of the interesting things about the C64 scene is that people actually look at your machine code. Not everybody, of course, but when a coder is intrigued by an effect, they will push the freezer button and look at the code. And so your audience is partly the people who are watching the demo, but partly the coders who are reading your machine code. And so you can do these things and it will still impress somebody. And even if the effect, I mean, then you have to tell people about it, of course. You have to put the text on the screen saying, how is this possible, or something. And then otherwise they wouldn't even look.
No, well, that's one of the things in panoramic design. They added silly cool effects, and they didn't have like a pointer saying this is where the cool effect is. They just
when you realize that there are 9 letters in panoramic, and 8 sprites.
Yeah, that one totally made me go bonkers before. I really needed to find out how they did that. I love that effect.
I did that something similar in Lunatico as well. When it says flip disk, there's also a picture of a floppy. So there are 8 things or 9 things in the border, but it's using the same technique. So it's, and I don't call attention to it in the demo itself, but it was nice to be able to pull that off as well. But they invented it.
Great. You referenced Christian Bauer's document before, and I should reference the fact that you have something called a VIC timing chart also as one of your publications, and you can see the VIC timing chart as a nice addition to Christian's documentation, a handy way to kind of document how the VIC works and what happens when on which cycle of every line.
Exactly. So it visualizes what's going on. And it's based on the VIC article and the VIC addendum, because when he wrote the original VIC article, the Sprite crunch thing was not known, at least not by him, and so it's not part of that, so they wrote an addendum. But that's also in the chart. And it was a way also for me to sort of, while reading all this, keeping it in my head as a beginning programmer on the C64. So this was a way for me to organize this material, and then I was able to present it in an organized way because of that. If I had grown up with a machine, maybe I had internalized the different parts one at a time and sort of wouldn't have the need for this chart. But then
again, I still appreciate you doing this, because sometimes a lot of people are trying to solve a problem, and then they just invest the time in solving the problem, and then they realize a number of things, and then they move on without documenting what they realized. And so it's sort of lost. You need to go into what they actually do to realize what it is. And that makes it very difficult for anybody outside to digest it, which is a bit of a waste. And you are doing the right thing here. You're also spending time to document it. If you do it for yourself, that's totally fine, but it's very usable also for somebody else. So again, much appreciation for doing stuff like that.
Thank you.
So, did you enjoy the video so far? If you did, then please do us a little favor. We're not asking for any monetary favor or anything in return. We would like to ensure that all people interested in this would see as much of it as possible. So what you can do for us is subscribe and also press this little clock icon to ensure that YouTube also notifies you when new material is released. But the predominant thing would be if you would be able to share the video with somebody else you think might be interested in it. If you post a link to it on your Facebook page or what kind of social media you are using, that will be so appreciated, because then we can reach out to more people who are interested in what we're doing. So thank you in advance. So now the really cool things, and to be honest, we are getting to the accordion, of course, but and to be honest, I think I've seen it shared by like 100 people, and I've also read like 10 articles where so this is if you have one claim to fame that reached well beyond the nerdy C64 sceners, it's the accordion thing. But we take one thing at a time here.
There might be one more claim to fame, though,
Yeah.
which is the Chipphone.
Yes, yes, of course. That is also here on the list.
Yeah.
So Parita Prelude, that's where it starts. It's not really an instrument as such, but take us to that.
So that project is a musical performance with Qwertuoso, which we talked about. So I can play melodies and chords on C64s. And then a variation of that tool, which plays the music on a floppy drive using the noises from the stepper motor. Because once I had like the program for mapping keys to notes, that was, I think maybe I was inspired by the great wild compo entry from, was it Quiz, who ran a demo entirely on the floppy drive. It was presented as a wild compo entry at the GubData, and he wrote a little text about the challenges in making music with a floppy drive. Of course, that demo is even more impressive because it makes the visuals as well. But that sort of inspired me to experiment with drive noise as well, and so I made this little tool to play on the floppy drive, and it turned out to sound good. And I like that piece by Bach, and this was, it sort of came together as a musical project.
Absolutely excellent. I mean, music on the disk drive, that has been around for quite some time. This bicycle made for two or whatever, that was amongst one of the early discs I had. I'm not really sure it's very good for the disk drive, is it?
I don't think, I mean, it is using the motor, so it is wearing the motor, but so would be when you're just using the disk drive normally. And maybe you're accelerating that a little bit, but you're not really abusing anything, I would say. You're just using it and using it a lot.
Okay, so I had one of those 1541, the VIC-20 white ones with the one that was 1540, and then basically the same thing was called 1541 as well, and it was white, and it was always out of alignment, so I had big issues with it. And so it's not because I played too much drive music. You could say that that's safely not the reason for it going down.
I'm avoiding the thing where the head is slamming against the case. So that's I know that can mess up the alignment. So I'm avoiding that, even though it would make a good sound in some cases. But,
there is a Polish guy. He has like
the
hundreds of 3.5-inch drive and printers and scanners and
that's an inspiration as well. The Floppotron.
Floppotron.
It's called. Yeah.
That's massive.
And those are, first of all, those are of course PC disk drives. Then they are also, as far as I know, he is making his own hardware to drive them. So you wouldn't be able to play that music when the disk drive was operating inside a PC. So my innovation, I mean, it's to play it live is a new thing, but then also to use it as a normal, in using the normal drive software, makes it different from, let's say, the Floppotron. Or there's another channel that makes music with electrical toothbrushes and things like that, which I also think is a great inspiration. But he is also making his own electronics to drive the motors. So, so I mean, it's part of the challenge, I think, to use the hardware properly, like a computer and a disk drive, and still get something new out of it.
Well, I mean, making music on anything is a challenge, but if you take it apart and not using the proper interface and connecting it the way it's supposed to be connected, then you can basically just buy another motor, and if you're just using it as a motor, then you can just buy the motor. And
exactly.
For me, that takes a bit of the edge out of it, and doing it live as well is also I couldn't play anything, so I'm impressed just that you make anything sound nice. So the Chipphone, again, the VSP thing was the first thing that really caught my eye, and the second thing was this. That's also what?
Yeah, that was a cool project. I mean, it still exists. I just found other things to do.
Yeah.
So my friend had this organ that he got from a thrift shop, I guess, or a second-hand, maybe a bit more fancy second-hand shop. I remember this when you go to these second-hand shops in Sweden, there's always an electric organ, like it's mandatory. They have one, and just one, and then if you buy it, I guess they take in another one. And some of those are
now we have room for one more.
Yeah,
or
exactly.
Another one.
So they were mass produced in the 70s. There are some antique models that you shouldn't rebuild, but those are typically expensive as well, so you wouldn't find them in those places. But this one was sort of mass produced, relatively cheap at the time, I guess, because they were switching out. In schools in Sweden, they would sing hymns every morning with a teacher in the old days. So the teacher had to be able to play the organ, and they had these little organs that you would have to pedal to pump air through the bellows, and they were changing those to electric organs in the 70s. So they mass produced them. And then when that era was over and everybody got a piano or maybe nothing, the aftermarket was flooded with these things. I just ripped out all the electronics on the inside and made my own, connecting one little wire from each key. So it was a lot of work. I made 1 octave at the time, I remember. So I could have played a little bit with that, and then I made another octave, so I had some more notes to play with to keep it interesting. And at the beginning, I had not made the connection to chip tunes. I was making MIDI signals and connecting that to an organ simulator on a PC. But then, at some point, I think I was connecting the dots, and I already had music routines for microcontrollers because of my demos on microcontrollers. So then I combined those music routines with my MIDI signals and started playing chiptunes on it. And I discovered that playing, for instance, Rob Hubbard's music live is really fun. I mean, not only is it good music, but it's fun to play. And that was a bit of a surprise, or it was unexpected. And so I recorded Spellbound as my first big release, so that I released on the same day as the presentation video. And then the presentation video went viral. That was the time when I think the biggest achievement was that I ended up on Slashdot. That was the big place to be in those days, and that brought in the millions. So the million views, I would say. I didn't earn any money on the Chipphone, but and I was approached sometimes to sort of monetize it, but I didn't want to do that because I didn't have permission to these tunes. So for copyright reasons, I was afraid to monetize that in any way. So that was just I took requests, I covered many Nintendo songs and C64 songs, and that was fun for a while. Then I had children. I didn't have any time, so I stopped, and then I discovered other hobbies, sort of. So it's still sitting next to me here. It's covered with some stuff. It turned into a shelf, but I mean, it still works. I did replace the microcontroller sound engine with Raspberry Pi, so it has more CPU power. I can get rid of the aliasing, and I can play more notes at the same time, but the functionality is otherwise the same.
You still take requests?
I still put the requests in the file. So I have this big list of requests. I tried to do a comeback. I did record 2 songs, and I didn't get the same overwhelming response, of course, and I still had other projects that I wanted to do, so it didn't take off that time. Maybe I'll do another attempt at some point.
Well, I mean, it's the first-hand thing. It's you cannot invent it a second time, because it's also the novelty of things that is
exactly.
sort of the thing. So. So the Thermin, one of my absolute favorite things in the world, because I love Midsummer Murder, and every time I forget the name of the instrument and what was the name of it, and then I Google it while watching the intro, and it's a massive instrument, and implementing it on the C64 was such an achievement. To elaborate more on that.
Yeah. So. I also like the Thermin. I mean, I saw a documentary. There was a documentary in the 90s where they interviewed Clara Rockmore, who was one of the first performers who mastered the instrument, and she knew Leon Thermin professionally. They worked together, and she learned to play the instrument, to play classical pieces, often with piano accompaniment. There was a documentary. I was intrigued by the instrument. I tried to. I had the idea that I would build one according to like the old schematics, the real thing. This was many years ago. Turns out you can't find those parts very easily. I mean, not only the vacuum tubes, but also some custom wound coils that it was more tricky than it was above my abilities at that time, but I was intrigued by the instrument. I got her Clara Rockmore's record, so I listened to these tunes, and then it turned up in Midsummer Murders, like you mentioned. It's a really cool instrument. It has made a mark on music history because it was one of the first synthesizers. I think the really first one was the Telharmonium, which was like a huge cast iron organ that would spin magnets around to create waveforms that they transmitted over telephone lines. And then they would have subscribers in hotel lobbies, for instance, who would hook it up to a speaker. And so and this was like huge. It was very expensive. They had to bring in funding, and at some point it wasn't economic anymore. And so, but it was the first electronic synthesizer. The Theremin was maybe one of the first 3 or 4. Then a Moog Robert Moog picked up the theremin, was inspired by it, and made his revolutionary electric analog synthesizers based on, in part, the theremin design. And Moog has also manufactured theremins, and I think they are still commercially available from Moog.
And for those of you who don't know what this is, you are sort of waving your hands, and the instrument is sort of detecting where your hands in, and the pitch and everything of what you're playing is depending on where your hands are. And the cool thing is, it's the only instrument which you basically don't touch.
I mean, variations have been made. There's like there have been other experiments where you control an instrument without touching it, but none of those have become like established musical instruments that somebody spends hours to practice and perform on. So it's unique in that way. And it turns out that it isn't that tricky electronically to make once you know what you're doing. So when I tried to do that and just copy some schematics, I didn't know what I was doing. But this year, I mean, I've learned stuff, and I figured out that it wasn't so tricky to do it. But then the idea of connecting it with the SID somehow turned into this vision of because the bread bin has a retro look. It sort of looks like the wooden box that the theremin also is. And then I had this clamp for the metal clamp that would work as an antenna, at least during development, just to try things out. And then it sort of stuck as a fun way to realize the antenna, and then to keep the funny thing and take it one step further, I used a spoon for the other antenna. And it works with any piece of metal. The bigger, the less you would get interference from other stuff nearby. But yeah.
Well, yeah. What about that? Did that become viral to the same extent as the Chipphone, or is that?
No, it didn't. I've been keeping up my YouTube channel and releasing projects, and I have a following. So when I release a video, I will get views from these people, and for a very long time, I would get, in the first week or so, I would get maybe 1,000 or 2,000 views, and then it would start trickling. Just so I knew I had a following of maybe 1,000 or 2,000 people, and it stayed that way for a very long time. And now with my Commodorion video, it's increasing suddenly. But I have no reason. I wouldn't expect this video to be so much better received than the theremin video.
Yeah.
I don't know why, but such is the internet.
For me, out of the ones we're discussing here, Thermin is still my favorite. And the piece where you kind of cut discs for the Commodorion is sort of, ooh, I hope they were broken discs. Otherwise, that's
they were
a
bad
shame.
discs. And I put up a text about that.
Yeah.
But I put the text up after a few seconds. Yeah. so you still have this gut reaction of no. Then you see the
no help to disc were harmed in the production.
Yeah, exactly.
So let's go into the Commodorion then. We have touched upon it several times already. So accordion is this bellow and two things, and you push it back and forth, and that makes sounds, and you try to re-implement that using two C64s and then a bellow that you made out of discs and duct tape, right? So
yeah, no, gaffer tape.
Yeah.
Gaffer tape. I tried first with some other kind of black tape, which had a sort of a gooey residue that didn't work very well. But when I found gaffer tape, that was the obvious way to continue. So a gaffer is a position that you would have on a theater or film stage. And what they do is they tape marks on the floor, so the actors know where to stand, so they are in focus by the camera. So somebody in the 19th century said that the accordion is an organ with lungs. So you have this ability to express musically by changing the volume of things to be more expressive, like a singer maybe, compared to an organ where you just have note on, note off. And on my Qwertuoso, so when I made the 64-gram project, I wanted the organ-like interface because I wanted to play organ music. But then when I recorded some other pieces on the C64 using Qwertuoso, I would have this little fader, or sometimes a rotary knob, that I controlled with my left hand. So I was playing melodies with my right hand and controlling the volume with my left hand to have this ability to express and do volume changes. And the bellows are just another way of doing that. It just controls the volume, but it adds a lot of character to the sound to be able to do that. So it's definitely doing something to the instrument apart from looking cool. The downside with the Commodorion, this is maybe unrelated, but it's an important thing to bring up, is that it's not very ergonomical. So when
it's heavy.
It's heavy. It's not much heavier than an ordinary accordion, but it is heavy. And because of how you need to hold it, the left hand needs to sort of stretch at a very bent angle like this for a long time. You have to reach far with the fingers, and at the same time you have to carry this weight, and that's not good for the wrist or the arm or the hand. So that's the sort of the downside to the Commodorion. It means that I can't really spend time practicing my left hand. I can practice the right hand because that part feels good, but the left hand I have to be careful with my body. As a musician, this is something really important, because you can mess up, so you can never play an instrument again, and it would this is something you have to be careful with. so I can play occasionally, and that's also partly why I made this rhythm box for the left-hand side, that you just control the loop, but you don't have to push as many buttons every second as you would have on a real accordion.
I mean, if this is like black magic to most of you, we should say that Linus is professionally doing musical instruments, so in the sort of crosshair between music and engineering. Teenage engineering is the thing, right? So
that's right. So I'm employed at Teenage Engineering. We make synthesizers and some speakers and some other toys for rich people. No, but it's no.
I think that's a fair market. That's absolutely a fair market. So don't feel ashamed about that.
No, but and also I think my colleague once noted that you should make expensive things, because if you make cheap things, they end up on a shelf. People give them away as birthday presents, and they end up on a shelf, and then they end up on a landfill. If you make expensive things, people care about them, and when they don't want them anymore, they sell them to somebody who will use them. So so there are many reasons to make expensive things. But of course we do it to make money. So,
I've been blessed to see your performance at the Data Storm, where this little calculator without the external shell, it's just like little tiny little buttons, and you made a live performance on that. And there are aspects of this that go well beyond me. I must say I was humbly impressed to just watch it. So so one of the other things that I recognize you for would be the setup you're using when coding. When going to parties, you have people, the kind of hardcore hoarders. I love the native hardware and I wouldn't want it any other way, using CRT screens and all of that. And then you have me, the laptop guys that want to do it the low threshold to any nuance, better keyboards and faster storage and all of that. And then we have you, not fitting in any category as ever. Using you had this little wooden board on top of your C64C, and there was some sort of circuit board, some Raspberry Pi thing, sort of thing.
Yeah, so this is, I will mention that this is not where I do the bulk of my coding. This is my party setup. But it's a little extension to the C64 with the Raspberry Pi on it. An early version was mounted on a wooden board. Then I made a proper printed circuit board. So it sits on the user port, and it talks to the C64. So the C64 is like a terminal. You type, and that gets transmitted serially to the Linux running on the Raspberry Pi, and the output goes back to the screen. It looks like a normal basic screen, but it's really not that. It's raster trickery and so on, because I want to be able to scroll quickly and to be able to scroll part of the screen quickly. So you're actually getting a raster interrupt every 4 raster lines and displaying the first row of characters over and over again, but switching banks. So each of the 25 lines comes from a different bank, and that's how I can do quick scrolling. So it looks like the basic screen, but it's something entirely different. As usually in demo coding, what you see is not what you think you see.
But so do you have like a cartridge image where you have like the core of the software, or do you need to load that in some way? Or
I need to load that, but I have that on 1541 Ultimate, so
okay,
it's really easy. And now with my own cartridge image, it's even quicker to just load that up, and then I get the. And I also have the ability. So I cross-develop on the Raspberry Pi. I cross-compile, and then I can send a program file over the serial port as well. So there's a way for me to run the program on the real machine. And then I can debug it using the monitor as usual, and then keep developing on.
I do fully acknowledge the fact that you need to, if you can send it to the real machine and run it, it's not emulation, and trickery that you are inventing might not work 100% on emulators because you're sort of exploring the edges of things, but it will always work on the C64 if it's intended for the C64. So that part I do understand. The part that is sort of is the fact that you're using the native C64 as a keyboard, and to be honest, the C64 keyboard was way better than the Spectrum, but it's still not a good keyboard.
Yeah, that's not a hard target to reach. But yeah, I like the C64 keyboard. I like mechanical keyboards, which I realize is a matter of taste. So if you like mechanical, then I think it's good. Though, yeah, it's a matter of personal taste, I guess. I have more problems with the Amiga keyboard, despite the nostalgia, having grown up with it. But now when I come back to the Amiga keyboard, I get very frustrated. So, I mean, it's a matter of taste.
To be honest, if I have to pick one, it would be the one from the 128D. That one I think it's quite fine. The C64, it's a bit too clicky. I've grown fond of a little less click than that. But yeah, again, it's a matter of preference here.
Yeah.
So, and this PASP64, is that the name of that solution?
RASP. I think it should say RASP64 because it's a Raspberry Pi.
Okay.
Yeah. So
excellent. And if I would like to use that, I would need to have your printed board and all of that. So
yeah, and I don't think I released that software either. But I mean, if you build the board, I'm gonna send you the software. It's like it's not a secret, but it's made for my own use, and yeah.
Well, don't worry, I will be using emulators. So.
Yeah.
But I don't do big trickery, so I can sort of rely on emulators. So they are good enough for my purpose.
Yeah, it's been useful for investigating things like the VSP crash, but also for the Ultimate Opus, where you have to interface with the 1541 Ultimate, because that is not emulated anywhere, and that software on the 1541 Ultimate is, or at least was, very buggy. So you really need to, you can't just follow the documentation. You need to dig into it and sort of try things out. And then you need to run it on the real machine.
So excellent. I've given up on us watching demos in the end. So we will have another session where we watch demos. So there will be another good reason to talk to Linus sometime in the near future. But we can wrap up with a few additional things I have. Your talk on poems for bugs. That's something that's available on YouTube as well. And I think it's a talk you had on one of the parties on sort of the
revision.
Beauty of making very, very compact code.
Yes, exactly. So I tried to give a speech about coding on the C64 that would have some appeal to a general audience. So it's you can appreciate some of the bits if you're a coder, but most of it is targeted at like the average demo party visitor, which would be graphician, musician, PC coder, for instance. And I bring up the sort of the unique bits of coding when you have to count the cycles and trick some hardware into doing things like opening the borders. How does that work even? Because there's no such thing on a PC for a PC coder. What is it? How does it work? And what's the beauty of it? And I sort of connect it to poetry, where you have syllables and you have to sort of get a meaning across, but you have to fiddle with the bits and count things in order to make a rhythm that works poetically. So
a syllable is the cycle here, or instruction.
Yeah.
And you can fit only a number on each row, and you want to convey a message. It's the analogy works. I get that. It's not one I have thought of, but it comes across really well. That comes across really well. So the syllables being the instructions, and you want to not just have the number of instruction that fits the format you have chosen. You also want to make a poem where the content gives meaning. So I think the analogy works here, and really brilliant. Well, we shouldn't end with other platforms, but that is sort of where we are at. So
I'll fix that in editing later.
You have done a few things for the other platforms that sort of I have picked up on, and that would be Warp Fruit and the 4096 bytes. That would be stuff you've done for Linux, right?
Yeah. So when I and my friends in Kryo, if we tie back to the beginning, when we were traveling to Swedish computer parties, there would be seminars and there would be people talking about size coding on the PC platform. And I'm not sure, I think they were targeting Windows, but the principles they explained seemed as if they would be working also on Linux. And so I made my first 4K intro, which had no music in it, which was a big mistake. But at least it was, and that's the one called 4096 bytes. And then for the next year, I made a 4K intro with music, and that's Warp Fruit. So yeah, I had.
It should be in the other order here then. So it's ultra small things, but you've done 256 bytes on the 64 with both graphics and music, which is...
That was much later. And that started as a way of, as an experiment to make music that was really small. And then it sort of turned into a demo, because a lot of the visual effects are just, you can read out from the SID chip, you can read out the current volume and the waveform, and you can sort of use that to affect visuals and sort of get something on the screen at the very low cost in terms of bytes.
I mean, 256 bytes. That, I guess the PC would need a header is bigger and all of that, right? So
no, really, the PC has a very interesting format. They have the .com file. And that's a file that gets loaded to a fixed address, and then the OS just jumps there. So it has no header at all. So the .com format is it's just, the format is the file ending. If it ends in .com, they just load it to $100 and jump to it. And so there's a scene of people doing small PC productions in COM format, because then you get a sort of a DOS environment, but you have all the power of a modern CPU. So it's a very strange and non-historic context, but it works as a platform.
Fantastic. Linus, I would go on for hours and hours, so we really need to schedule something where we look at your demos, because I would like to have like your expert opinion, your director's comment on a few of your productions to see what's actually happening on the screen. But unfortunately, Linus is pressed in time, and this Zoom account is also due for some other use within a few minutes. So we would need to cut for today, and it's been an absolute pleasure, Linus, and I will forever treasure the fact that you have LFT as your handle, as a sort of a mockery of FairLight. I think that was a very cool new thing. If you haven't heard it before, now you have. Yeah. Thank you so much for taking the time.
Great and thanks for having me.
Excellent. Bye-bye.
Bye-bye.
Was this everything? No, it really wasn't. So I did a compilation of all the things I would like to talk to Linus about. And as you already know, we had to skip the demos. There will be another session sometime in the near future where I have like the same sort of chat with Linus, but where we are showing his demos and he could give like director's comments on them. So explaining the effect that is sort of in operation when we see it. But there is one of the additional thing that Linus has been doing that's also mind-blowingly cool. It's to the best of my knowledge, it only exists in like one single item, but that's one thing I would really like to buy and just have at home, but I really don't. And that is a Dial-A-SID. So it's an old plastic telephone. And that one with the rotary dial, one that anybody under 25 wouldn't have any sort of understanding on how to use. And then there is a massive phone book, and you can use this thing and you dial to sort of communicate with it. And then you sort of create a playlist of playing SID, because it has the entire high voltage SID collection in it. And you interfaces using the rotary and add a little button for adding stuff to the playlist. So let's, as a little bonus extra here in the end, have Linus show how that one works. So again, over to Linus.
Over 2,000 hours of SID music. That's the high voltage SID collection, which is a huge actively maintained database of SID tunes. All that music is in here. And by default, if we turn on playback, it'll just play random tunes from the collection. So, pick up handset, dial code for desired tune, composer or year, listen in handset, push green button to add tune to playlist, and hang up. Let's try that now. I'd like to hear something by Hubbard. H. Hubbard, Rob, here we go. Here's all his tunes, and let's pick Thing on a Spring, 67540. Now we have Thing on a Spring in the receiver. Now we can add that to the party playlist. The jukebox was just playing random tunes because the playlist was empty. But now we've queued up Thing on a Spring to play next. There's actually a special number you can dial to skip ahead to the next song. On a real party it would be rude to skip other people's songs, but let's do it now. So we dial 01. And here's Thing on a Spring. You may have noticed that in the phone directory every composer have their own number as well. When you dial that number you get a random tune by that composer. So let's hear a random Galway tune. G. Galway Marty 77700. Let's have another one. Good. Let's add it to the playlist. And skip ahead.
Wow, this was a long one. I hope you appreciated this. I know it's taken 2 hours, and it might be that you digested it during several sessions, and yeah, that's absolutely fine. Possibly we should have them shorter. My experience is only that if we make them into 2 halves, people watch the first half and then sort of skip the second half. And that is sort of a shame, because sometimes the best part of the discussion is actually in the second phase. For instance, the interview with the Sarge, I would say that the first is about him, and that's super interesting. But the part which was seen by less than half of the number of people that saw the first part is watching him actually draw stuff. And to me, that would be more interesting for most people. But that could be me. And the same is actually valid for the interview with Black Shadow. The one we split that one as well in 2 sections, and the first one was watched by a number of people. And then the second one was only watched by like half of the number of people that saw the second part. So, which is a shame. And so do look up those part 2s if you've only seen the first one. But this is still everything you get. It was a lot, so I'm not saying this is everything you get, assuming that it's sort of little, because I know it's a lot, and we do appreciate that you take the time to watch this, and it's sort of we pride that you watch all of the content that we're doing, and we're so grateful that you take the time, and we really appreciate doing something that you fancy so much that you want to watch it for 2 hours. So thank you so much for spending the time, and hopefully I will be able to provide something for you until next week. But if not, then until next time. Bye bye.